Before we get started, I just wanted to mention that we have now opened registration for the next OpenShift Commons gathering in Amsterdam. That's co-located on day 0 with KubeCon in Europe on March 30th. And the fun news about this, if you are a container storage person or interested in container storage at all, we are hosting a half-day hands-on workshop at the OpenShift Commons gathering, and it's called the OpenShift Container Storage for Admins Hands-On Workshop, and you can sign up for it as part of your registration for the OpenShift Commons gathering. There are lots of other wonderful things going on as well on the main stage and other ones too, so we hope you'll join us in Amsterdam, and you can register today, and it's open, and it's only 49 euros, and it's probably your best deal of the week. To get a whole lot of information about what's going on in the Kubernetes and OpenShift ecosystems. So with that, I'm going to hand it over today to Venkat Kolli, who is now going to share your screen and take over and give us a wonderful talk on backup and disaster recovery. So Venkat, you want to take it away?
Thank you, Diane. Hello, everyone. Let me introduce myself. I'm Venkat Kolli. I'm a product management director in OpenShift Storage. So OpenShift Storage is OCS, as it's called, is a native storage solution for OpenShift. So specifically, we're going to be talking about data protection and disaster recovery solutions that you should consider when you're deploying OpenShift. And in this session, this is a brief overview. We're not going to be going into technical details on the multiple solutions that we'll be talking about, but wanted to give you a quick introduction to how you plan for these solutions. When do you need, what kind of solution is needed for what kind of situation, right? And how do you generally go about thinking about these solutions? So think this as like a primer for your data protection and disaster recovery. And in the later on sessions and also in the OpenShift Commons that Diane mentioned, we'll be going into a lot more technical details on how the specific products and features that are associated to this to these functions work. But for this session, we're going to give a general portfolio overview. Okay. So having said that, let's dwell right into it. So when you think about backup and DR, I mean, obviously these are the solutions that are, meant to protect from your failures. And
hey, Sandeep.
Hello. There seems to be a crosstalk. So not all failures are the same, right? So if you generally look into the failures that impacts your applications and data, right, you can broadly categorize them into 2 broad categories, right? So one is logical failures or software failures. These could be, user errors where somebody accidentally deletes a file or someone intentionally deletes some data, right? And your software bugs or some virus and other malicious software impact. So in these failures are the ones where there's something wrong with the application logic or the application data, right? But your hardware is intact, right? Your data center and hardware is running okay, but you lose either a piece of data or an entire application itself got corrupted. So in this case, the most logical thing to do is for you to go back in point in time, right, where before the failure has occurred, and take a good copy of the data and restore it back to your primary cluster. Right, so because your hardware is running fine, your cluster is not impacted from a hardware standpoint. So the quick recovery mechanism is, going back in point in time and recovering from there. Yes, it does involve a data loss, but at least you have a good copy to start off with. Right. So this is where the backup solutions typically dwell on, right? So this is how the backup solutions work. So they basically are built for software failures and maintains multiple copies to recover from. In fact, the right word to use is restore, right? Restoring the data. And you have this other class of failures, generally, which are less in less common, but have much more a devastating effect, right? So this is where your hardware failed, or could be your whole data center has failed. The hardware fails either based on some components, I mean, disk drives, or or some other part of your hardware that fails and takes away the node of the cluster, right? Or you could have an HVAC issue or a power grid issue where your data center is down. Right. So in this case, obviously, you cannot wait for this to be repaired and recovered. Right. So the recovery mechanism is that you fail over to a remote site that you previously set up and where you've been copying the data to, all right, and move your applications running off from your DR site. Right. So this is your failover to either a standby or a hot site. And we'll get into the details about the different DR sites that that mechanism to have. So these are the DR solutions. These are typically a function of a storage, the underlying storage, and right. So that basically protects you from your physical and data center failures. Now, the common tools and technologies that are used for data protection, I mean, these are like a very common set of tools that are used. So let's start off with, say, data mirroring. So data mirroring is essentially a synchronous mirror copies that most modern applications and storage systems do. Right. So whenever you're writing, an application is writing a I/O or any transaction is being complete, before the transaction gets complete, it synchronously makes sure there are more than one copy. It's write to more than one place, and they're always consistently and mirrored. So you always have a full consistent copy before the transaction or I/O is complete. Right. So this way, even if you have a node or a single copy failure, without application, without a beat, can continue running on the other good copies. Right. So there is no data loss here or any application downtime with the data mirroring. Obviously, it comes with some limitations, and we'll go through this in detail later. But that's essentially what the data mirroring is. So just as an example, the OCS, which is the native storage of OCP, does have a native data mirroring mirroring built into it. So by default, it always writes 3 copies and consistently keeps them copies synchronously mirrored. Right. So that's data mirroring. And snapshots, most of you probably already know and heard about snapshots. All right. So this is basically where you consistently take point-in-time copies, right? And you keep a set of them. So when you need to go back to a previous copy because your latest copy, either your latest data is either corrupted or lost, right, you can restore from one of these point-in-time copies. So this snapshots typically it makes the core foundation of any backup solution, or sometimes even the DR solutions, right? And building on snapshots are the backup applications. So backup applications essentially take this point-in-time copies. Now they schedule them, right? Or you can set up, certain, some mechanism where you can have certain policies where you can actually, keep those copies either locally or remote, so that you and also restore from them when the time needs. So this is essentially an application. Typically, in most traditional enterprises, you have a full-blown backup applications that are built with very rich backup policies, all built into them, right? So that's basically a backup solution that is typically built on snapshots. And lastly, the other common mechanism to use for data protection is data replication. And again, this is a storage function where you're now asynchronously copying the data to a remote destination. right? So this allows you to basically have the application run on that remote destination because you have a copy there. But the difference between the mirroring and replication is that mirroring is always synchronous and is always, or is always in sync. The replication is asynchronous, which means that it is copying at a scheduled interval. And I'll talk about the pros and cons of setting up those schedules and what are the things that dictate these schedules. But that's basically what the data replication is. And most DR solutions are built on this data replication. So these being the common tools, so how do they come together? So when you think about data protection solutions, right, so you basically are driven by what is something called SLO, right, service level objective. So if you take an application, you got to determine the business value of that application and how much service or how much critical is that application to your business, right? And based on that, the most common two metrics that are used are called RPO and RTO. And they constitute what a service level objective is, right? What your SLO or SLA for that application is. RPO is something that how far do you want to be, copied, or how far or how much data loss are you willing to suffer, right? And now that sounds bad, right? No one wants to have any data loss, obviously, right? But protecting without any kind of data loss obviously gets more expensive. So you have to rely on more expensive solutions. But if the business calls for that, yes, you go to the most critical zero data loss solutions, right? But not all applications might require that level of guarantee. So you can have options to go to a previous, to more loosely, defined solutions. And on the other metric is the RTO. So this defines how quickly do you need to bring back up, right? So if your application incurred a downtime, how quickly do you need to bring that back up and make it into running? And just as before, right? Obviously, you don't want to have any application downtime, but again, for that to happen, right? It requires expensive solutions. So you have to basically make a judgment on, where do you lie on the spectrum of RPO and RTO. Right. And if you look into solutions that we just are talking about, so for example, the mirroring is the one that basically provides you the most consistent copy without any data loss and also helps you to recover automatically, right? So this is getting close to our zero RPO and zero RTO. With that, obviously, solution gets expensive, right? And especially if you are trying to protect it from many other disasters that are more geographic in nature, but we'll get into that later. And getting on that scale, a little bit more, looser application of that is replication, right? Where you're replicating the data to a longer distance. So that obviously might involve asynchronously, that would involve, some data loss, but you're protected against more types of disasters with this solution, right? And both replication and mirroring are built for hardware failures, right? Are built to protect against the hardware failures. And going further back in the scale, so you have the snapshots, right? And again, depending upon your needs, you set your schedule for snapshots. You could take snapshots every minute or every few minutes or hours or days. And you can define your retention of those snapshots as well, right? So that's basically helps you to go back in point in time. And backups are also, the modern backups are all online and are basically stored on a disk. So where you can actually have a quicker access compared to the tape backups, which are traditionally used before. But these days, most modern applications and modern data centers are all using disk backups, which is much quicker for recovery, right? And also helps you with the testing of those, backup copies. But for the data that you really need to retain for very long periods of time, either by, because of regulatory reason or business reasons, where you want to keep the data for years to come, the disks are not a good solution for that. So that is where people copy to tapes and archive them to a remote site, like Iron Mountain and a few others have services, protecting those tapes. Right. So that is how the solutions are laid out, and based on your RPO, RTO needs, you choose the right solution for that. So getting into a little bit more details onto each one of them. So start off with the data protection with the snapshots and backup. So this is where I said, right, based on snapshots, you build a backup solution on it. So the snapshots are always point-in-time copies, and most modern storage systems, provide you incremental copies. So it's not like a full copy every time you take a snapshot. You have a full base copy, and then all the other copies later on are basically incrementals of those copies. So you basically, from a storage standpoint, and also from time it takes a snapshot, is a lot more quicker. And a local snapshot is your first defense of protection, right? So these are located on the same cluster and is taking up the same space as your primary cluster, right? And you can quickly recover because it's local on the same node, also on the same cluster. So whenever you have a failure, or if you lose a file, or have some data loss, right, if you have any failure incident, you can quickly go back to your point in time and get that restored from there locally. Now, why wouldn't anyone use this, right, as their only backup mechanism? One is obviously because you're using your primary storage. So as you increase the number of snapshots, one, it is eating up your primary storage capacity. So there's your capacity left for your applications to run gets limited, right? And also could be expensive because most likely you'll be using a high performance storage, SSDs or NVMe drives, etc. And there, and you're basically using that space for your backup copies. And also the other thing to consider is that as the depth of the snapshots, and when you say depth, it's the number of snapshots that you're retaining, right? As the number of snapshots that you're retaining goes higher, there will have an impact on the application because these are point-in-time incremental copies. It's primarily a snapshot that's created by a pointer mechanism. So you have more processing that needs to be done, the more snapshots you retain, right? So that's the reason why most systems limit the number of snapshots that can be retained on your primary cluster. So the other downside, obviously, is that if you lose your primary cluster or any nodes, you lose your snapshots along with it. So that calls for the snapshots to be stored and backed up to a remote destination. So that is where the backup solutions come in, right? So the backup solutions essentially are taking the snapshots and copying to a more cheaper or external storage. Typically S3 object store is a more common way to, getting more common for these backup targets, right? And these scale well and they're also, as I said, much lower cost. So, right. So you can have more backup copies retained on this. And this object store could be located far out for more disaster-like scenarios, or could be within the same campus or metro network, so you can have a quick recovery happening from there. Right. And by the way, the same mechanism where you're backing up to a remote destination can also be used for migrating of the workloads. So in fact, OCP has a migration tool you probably might have come across called CAM. This is actually built on the same backup mechanism that that we have built. So, and in one of the follow-on presentations, we can go in more details on how that works. But this is also a common way to use for migration. And the other aspect to consider for the backups is that so these are managed by policies. So you can actually schedule, set up a policy on whenever you're creating an application or a volume for that application, right? You can basically define your scheduling and retention policies, right? Oh, I want this to be backed up every 15 minutes or every hour, and I want to be retained for 7 days or for a month, right? So these scheduling and retentions are basically specified in the backup policy, and these backup policies could be codified into storage classes. So you could actually have a predefined storage class. So storage class is a way where you can, define your dynamic volume, right? Your PVC volume, right? So you can basically create a storage class and define these policies into the storage class. So if somebody has chosen a gold class storage, right, they come up with a very frequent, snapshots and right, and have a longer retention, for example, right? So on and so forth. So that is how the the backup policies are defined and used in the OCP. So we just talked about the storage here, storage backups, but backup is not just about the storage, but about your entire application. And Kubernetes allows, and specifically OpenShift, allows you to actually have your backup defined at an application level, right? So you'd want to have your protection for a consistent protection for your whole application rather than on a volume by volume basis. Right. So what does an application level backup consist of? So start off with at the core, obviously it is storage, application data, right? So these are your PVs and PVZs belonging to the application to protect from. And the storage interfaces that are used are basically called CSI, which are basically a common set of standard interfaces that are used to create these volumes. This CSI interface is also being expanded to cover snapshot functionality, right? So the snapshot interface is now getting standardized with the CSI interface. Right, and this is currently in beta, but it's going to go into GA soon in few releases. So at a core storage level, so you have the application volumes getting snapshotted through the CSI interfaces. Now, coupling with this application data or application volumes are the cluster resources, right, that are associated to this application. So when we say application, what does application mean in Kubernetes, right? You can basically, define it as a namespace, right? You can basically say that, my application is specified on a specific namespace, or you could say that, I will have a label that's created and associate and tag all the pods, containers of application of interest in one label, and I could basically want to back up based on that label. Or I could say that I want to back up this entire namespace, right? Or every application component of that namespace needs to be backed up. And when we talk about that namespace level backup, so we're not just talking about the application data, the application volumes we talked about before, the PVCs, but also the cluster resources that belongs to this namespace. So these are the namespace projects, your deployment stateful sets, right? Your config maps, secrets, and YAML files, everything that is associated to the namespace. So when you are able to back up, right, your application data along with the cluster metadata, right, now you have a full namespace or application level consistent backup. Right. So for you to be able to either migrate this application or restore this entire application, it is much, much easier if you're able to have one consistent copy that covers both the configuration data, cluster configuration data, and the application data. Right, and that is what Kubernetes allows, and specifically we are building into OpenShift. Again, as I said, more details, more technical details we'll cover in the follow-on sessions. But I just want to kind of quick give on how OpenShift allows you to basically provide application level backups. Now, building on, so now you covered up to the cluster, right? So you have a whole cluster covered. Now the specific applications running on the cluster also require specific procedures for them to be run when you restore them, back, right? Once you have a consistent copy that covers both the cluster metadata and the application data, right? Now the application should be able to use that consistent copy and needs to perform certain functions to be able to, when it's during the restore. And this is happening through the operators. Right, so most applications have built-in operators, and even at the storage level, there are storage level operators that helps you to bring back up these applications and follow all the procedures that are needed, right, for you to, during the restore. Not just during the restore, even during the taking of the backups. Sometimes, for you to be able to get a crash consistent copy meaning that, if there's a system that is going down, you have a copy that is good. Just before that crashed, right? So which means that a group of the volumes are all consistent together, right, before the time of the crash, right? So that requires quiescing of that application. That requires the application to flush all its caches and all its data to the persistent storage, right, so that a snapshot can be taken. So that's a quiesce operation of their application. So all of these procedures can be automated with these application operators. Right, and the backup solutions typically provide specific application agents to do that. Right, so combined with these application agents and with the cluster metadata and the application data forms the full application level backup solution. So specifically for OCP and OCS, so OCS is built with the incremental snapshots that are built with CSI that are going to be introduced soon. And OCP uses Velero, which is an open source backup solution, to be able to provide a consistent cluster consistent backup at a namespace level. Right, and working along with our backup partners, we'll be able to offer a full-fledged backup solution at an application level, for OCP users. Right, so that's a quick overview of what the backup solution is. So quickly moving on to the DR. So this is basically DR, as I said, is a solution built on replication. Right, it is where you're asynchronously copying the data to a remote site and these remote sites are scheduled, are set up at far enough distances where you're not affected by, you're protected against any geographical failures, floods, fire, or power grids, or any of that. Right, so that's what typically you define your blast radius, which is basically what defines your protection failure you're protecting from. What gets impacted, during that, in the distance. So you schedule your DR site and connect that by WAN for that is beyond the blast radius, right? And because you're relying on an asynchronous replication to protect against these failures, right, there will be a data loss involved, right? So there will be not a solution where you can protect from without any complete data loss, right, to protect against this long distance WAN in a WAN DR. So typically when we talk about the asynchronous volume replication, again, this is done at the storage level. All the volumes belong to the applications are consistently replicated to the DR side. Right, and the schedule that you set up for this replication really depends upon what your RPO needs are. Right, again, how far are you willing to lose the data? Now, if you want to schedule at a very frequent interval, like even seconds, it is possible. However, your network also defines the bandwidth. You need to have enough bandwidth, network bandwidth, to handle the data, right? So if you're doing a very frequent replication, which means every change that is happening in that very short interval needs to be transferred over the network to the remote site. And if your network cannot handle that, you get congestion there, and obviously you will fail to keep up with the changes, and that impacts your applications. So both your RPO target and your available network bandwidth defines what your replication interval would be. right? But one positive aspect of this is that because this replication is async, your application is latency doesn't get impacted, right? So because you write your data to your primary side, and your replication takes over later, right, to make the to keep this changes transferred over to the remote side. So that's basically on the asynchronous volume replication. And I said this is a storage function, mostly done at a volume level, but there are also some applications that handle the changes and replication at the application level, but those are less common. Now, so that is making the data available to the remote side is one aspect of the solution. So the other key aspect of the DR solution is the failover itself, right? So it's the process of where you're transferring your application from your primary site, which just failed, to your remote site and make the application, bringing up the application there and, going over through the recovery process there. Now, one thing good about OpenShift and Kubernetes is that this failover mechanism, which typically is mostly manual in the traditional world, can be fully automated with the operators, right? So the same operators today that we use to bring up your applications on your primary site, we use the same mechanism to have an automated failover management done, and even failback. Failback is something where once you fail over to your remote side, you repair your primary site, and then once your primary site is repaired, you want to get back to your original state, right? So that's a failback to your repaired site. So both this failover and failback can be automated, and since these are automated, you can do this. You can achieve a very quick failover, so which results in a very low RTO, right? Recovery time objective. If it's a manual set of operations where you have to follow 10 steps for this application to be brought up, which is typical in the traditional world, right? That takes a much longer time. But with this, this allows you to have a very quick, recovery of the applications. This not only helps you during your failover, failback operations, but also the more frequent testing that you do. So once you set up a DR site, most companies require you to do test for readiness of this DR. So you actually have DR testing mechanism that also can be done through the operations, the automated operations. So that also helps you with the very quick thing. So one other thing to note is that remember we keep using the word automated, not automatic, right? Because it's always triggered manually. No one wants to have an automatic, which means a non-manually intervened failover, because it's an asynchronous DR solution, there's always a data loss involved. So there's always a judgment that has to be made whether you want to fail over to the remote site once you declare your primary site inoperable, right? Or you want to invest in bringing your primary site back up, which could be quicker and where you don't need to incur a data loss, right? So there's always a judgment that needs to be made. So so it is always required for a manual intervention to be made. But once you decide to fail over, you need to be able to just click one button and do an entire failover very quickly. So that is automation, right? And in the case of OCP and OCS, right, so we do have the Ceph asynchronous mirroring that does the data mirroring or data replication solution at a volume level. And we have the storage operators that helps you to restore your volumes and your applications back up, right? So this is basically using our OCS Rook operators. So now you have both an automated failover management and an asynchronous mirroring built into the OpenShift storage, right? And as I mentioned before, we'll get into more details in the follow-on sessions, but that is how the solution is defined for asynchronous replication. Now, getting into more critical applications, where you would want to protect your data without any data loss and want to have a automatic, recovery, right? So now we are in the spectrum of data mirroring solutions, right? And that helps you to mirror synchronously without any data loss. Now, these also kind of fall into your HA category, right? So HA and DR, they go hand in hand, and especially, this is a case where, some of them call this to be an HA solution, a high availability solution, right? That also can work as a DR solution if you use it effectively. So here, what we're really looking at is that your DR sites are basically defined either as an availability zone, right? And availability zone is defined as something that has a full a full protection of your failure domain, right? So all the resources that are defined are as specified in availability zone are redundant and does not get impacted by either failures in the other outside of the zone, right? So this is your basically defined failure domain. Right. So, and typically when customers define availability zones, they set it up such a way that your HVAC or your power grids are basically not crossing over the zones, right? So they basically are set up in places where the different power grids or your HVAC systems are having redundancy for each of these availability zones. This could be as simple as a rack, right? A rack level zone, or it could be like a data center build or a building and campus as an availability zone, and you have your next zone in a different building in the campus, or they could be spread in a metro distance, right? So you could have it in one across the town from each other. Right. So this is a place where you need to have 3 availability zones because it's always an odd number is required because of the quorum issues. Right. So you need to have 3 distinct availability zones, and they could be data centers, 3 different distinct data centers. Right. So that's basically what the setup is for data mirroring. And in this case, the storage is synchronously mirroring at a volume level, or some of these modern distributed applications also does the mirroring and maintaining 3 consistent copies. And what OCP ensures is that these copies are distributed across 3 different zones. Right, and even when a cluster is set up, it ensures all the resources that it's scheduling is scheduled into these 3 distributed and scheduled across into these different zones. Right, so you will not end up in a situation where you will have 2 master nodes, for example, running in the same zone, or some of the zones are not covered, without the resources. Right. The other aspect to remember is that latency between these zones, the network running between the zones is very important, right? So because these are synchronously copied, so the more latency the network incurs impacts your application, right? So typically you should not exceed more than 10 milliseconds of latency, for your networks between these zones, right? So, and as I said before, once you have this set up, OCP by default essentially schedules your resources across 3 different zones. Right. So that's basically what the data mirroring solution is, and the traffic is handled through your HA proxy or load balancer running on top of it, right? So it knows essentially where all the copies are, and even if a single zone or a copy that has failed, it distributes the load across those 2 other remaining zones. Right, and that's a solution that does not incur any data loss, and you have a full, solution that has an automatic recovery and no data loss, right? But obviously, this can be used for solutions that protect against a big blast radius, which means that any major geographic failures, events like earthquakes or fires, you get impacted by all 3 zones gets impacted by that, right? So it does not protect you from those failure events. So given these 3 solutions, your backup and your asynchronous DR and your data mirroring solutions, right? So as you could see, each of them covers different failure scenarios and provide you options, different recovery options for against those failure scenarios. And now the more common way is, the users tend to use all 3 of them or a combination of them. together to come up with their their protection mechanism for for your application, right? So you start off with hardening your primary site with with this multi-zone solution that I talked about, the stretch clustering, right? So this is where you can actually have your primary site, your primary data center, defined with the 3 different zones, and you have your cluster, spread across these 3 zones and hardened accordingly, right? So any hardware nodes, you still can keep running on your primary site without having to have a failover, and your application runs without missing a beat. Right. Now, combine that with the DR solution. Now you have a solution to protect against the geographic failures, right? So you have an asynchronous data mirroring that is done from your primary cluster to a remote cluster, right? Now you have a geographic protection against geographic failures, right? Obviously, this would incur data loss, but again, you have failure against most major disasters with this, right? And along with that, so that handles your physical or data center failures, and you combine that with your backup solution that handles the logical failures as well, right? Now you have previous point-in-time copies that are stored in a remote site, right? And or cheaper object storage, and that helps you to go back point in time when your latest copy is no longer good, right? So the key difference you might have noticed here is that with the DR site, you always have your most recent copy available and replicated to the DR side, right? So you're trying to recover to your most recent copy. With the backup solution, you're choosing your previous point-in-time copy when the most recent copy is corrupted, right? So if you have a corruption on your primary site, the same corruption gets replicated to your DR site as well, so it doesn't protect you from a logical failure. That's where your backup solution with your previous point-in-time copy comes in. Right. So the combination of your site-hardened multi-zone stretch clusters and with asynchronous DR-based remote disaster recovery solution, and with your backup solution, you're pretty much covered against all types of failures, and have achieve different RTO needs for different applications, right? So that forms the full solution suite. What you have available for OCP. So in the later sessions, we actually will go into more technical details on each of them, and how you configure them, and what the other considerations that you have to take. But I hope this gives an overview of what the solutions that are available.
All right. Okay. We have one question in the chat from Rav. He's asking, what might be better to have, multiple small clusters rather than a large single cluster for fault isolation?
That's a very good question, Rob. And so clearly, your data protection, policies gets defined by that. And in fact, there are multiple factors that drive your cluster design, right? Whether to have one large cluster or multiple clusters. And if you look into where the community is moving and what most of the thinking is going, right? Most people are leaning towards having multiple clusters, multiple small clusters that are defined for each specific workload, right? Because there are a lot of innovation happening in this multi-cluster management, right? Or a federation of the clusters. So you have tools and technologies that are being developed to handle the management. Your default domain is your failure mechanism. You're isolated from the failures from the rather than having from one large cluster, right? And that's also very different from a traditional world. Traditional world, because there are not very many tools. These tools that comes with the OCP. So customers tend to have one large shared data center or primary domain, right, where they have a mix of applications in there, right? But OCP allows you to have multiple clusters and manage across the clusters. So you should be leaning towards more granular clusters.
All right. Then there's one more question. again from Rav, how much is performance impacted during the backup across clusters?
Yeah, so backup of all these tools actually has the least impact on your primary application performance, right? So because as I said, backups are built on the snapshots technology, and typically what happens is that when a backup needs to happen, right, it takes a quick snapshot. First, it needs to quiesce the application to get a consistent snapshot, right? So that's the primary impact of the performance. But these days, these most modern applications have a quick quiesce mechanism where it flushes the cache onto the disk, right, and momentarily freezes the transactions. And because these are point-in-time copies, especially the OCS of the storage of OCP supports the point-in-time copy. Snapshots are instantaneous, almost instantaneous, right? Once the snapshot is taken, your application is free to move on, and the backup process happens thereafter, right? So all the backup of that thing is going to be done, but your application is not impacted by that. So of all the solutions here, backup has the least impact to your application.
If people had more questions, you can always check out the OpenShift products page with container storages, and there's links there to all of the different pieces of the container storage solutions and these backup and disaster recovery pieces. And you can always reach out to Venkat Kolli directly and find him on the internet. As well, I'll just reiterate again that we are, share the picture. We are hosting a deep dive workshop in Amsterdam in a couple of weeks, or a little more than a couple of weeks, on March 30th at KubeCon, and you can register for that on commons.openshift.org and sign up for the container storage workshop, and we'll happily dive in and answer any of your questions at that event as well. So that is the Container Storage for Admins workshop on March 30th. So space is limited, so please do register now, and you can find the links for that on commons.openshift.org.